Hi all, welcome to the part 6 video of the chapter Polynomials. In this class, we shall cover an important topic, that is remainder theorem. So let's begin the class. Let us go back to our previous example itself, wherein we divided the polynomial 3x square plus x minus 1 with x plus 1. So first, let's write down the dividend, divisor, quotient and remainder separately. That is, the dividend is 3x square plus x minus 1. Divisor was x plus 1, right? Quotient is this, that is 3x minus 2, and 1 is the remainder, right? And I have indicated on how to denote these dividend, divisor, quotient and remainder. P of x is used to denote the dividend, that is inside whatever is inside is called dividend, and whatever is outside is called divisor, that is g of x. Quotient is q of x, remainder is r of x. Okay. Now there is a very important link between the dividend, divisor and remainder. Let's see what it is. Now consider the divisor. Okay, this divisor is a linear polynomial, right? In this case, we can draw a very important link, that is, let's find the 0 of this divisor polynomial, that is x plus 1. So g of x, right? So let's find the 0 of this divisor polynomial, that is x plus 1 is equal to 0 implies x is equal to minus 1. So minus 1 is the 0 of this divisor polynomial. Now let us find the value of dividend polynomial at minus 1. So we found the 0 of this divisor polynomial, and then we are going to find the value of the dividend polynomial, this polynomial p of x at minus 1. So that is, instead of x in this dividend polynomial, we will substitute minus 1. So 3 into minus 1 square plus minus 1 minus 1. So this is 3 minus 1 minus 1. That's 3 minus 2 is equal to 1. Now, what is 1? Isn't that the remainder? Right? This is r of x, right? So this theorem, wherein we can find the remainder from the dividend and divisor, that is, if we know what is the dividend and divisor, and if the divisor is a linear polynomial, then we can find the remainder directly without doing all this long division. This theorem is called the remainder theorem. So the remainder theorem goes like this. Let P of the remainder theorem goes like this. Let P of x be any polynomial of degree greater than or equal to 1, and let A be any real number. Okay, this is just an introduction, that is, P of x should be a polynomial of degree greater than or equal to 1. Okay, and A, let's consider A as a real number. Then if P of x is divided by any linear polynomial x minus a, so we have given a format for g of x. That is, before we told that P of x is divided by g of x, right? But this g of x should be in the form of x minus a. That is a linear polynomial. So if this g of x is in the form of a linear polynomial like x minus a, then the remainder of this division will be p of a, will be the remainder. That is the remainder theorem. I hope it is clear. Here x minus a, from this linear polynomial x minus a, we need to find the 0 of this polynomial, and then we will find the value of p of x at that value. That is, in this case the 0 of this linear polynomial will be a. So thus the remainder will be p of a. Let's do one more example and see if the remainder theorem is correct. Here in this example, we need to divide this polynomial, that is 3x raised to 4 minus 4x cube minus 3x minus 1 with x minus 1. Okay. So when you have been given a polynomial, make sure that you write the polynomial in a standard way. That is, you write each term of the polynomial in the descending order of the degree. That is, first it is 4, then 3. So that is, it is decreasing. The degree is decreasing as you move on. Okay. Similarly, in the case of the divisor also, you need to write it in a particular standard form, that is in the decreasing order, that is the terms should be in the decreasing order of their degree. Okay. I hope it is clear. Decreasing order means this is 4, 3, 1, like that. So the degree is decreasing. Alright, so let's begin the long division method. So as we have discussed before, for long division we need to take the first term of the dividend and the first term of the divisor. That is 3x raised to 4. We will divide it with by x. Okay. So the answer will be 3x cube. So we will write that here, 3x cube. Then we will multiply the quotient that we got with the divisor, that is 3x cube multiplied by x minus 1. So this will be 3x raised to 4 minus 3x cube. Okay. So we need to write this product here, 3x raised to 4 minus 3x cube. Now let's subtract these. While subtracting, you need to change the sign. So this is negative, so let it be, it will be positive, and here the sign of 3x raised to 4 is already positive, so it will change to negative. Now when you subtract minus 4 x cube plus 3x cube, right? Here the answer is minus x cube. So let's write that here, minus x cube. Here it is 3x raised to 4 minus 3x raised to 4. So it will get cancelled off. Here the value will be 0. Since it is 0, we will not write it down here. Now we need to bring down this term, that is minus 3x. Alright. Now let's repeat the step again. We will divide x cube with x. X cube with x, the answer is x square. It is minus x cube. If you notice, it is minus x cube here. So we have to take minus x cube by x. Answer will be minus x square. again multiply minus x square with x minus 1. So you need to each time you need to multiply with the quotient you got in that step. So in this step the quotient we got was minus x square. So it is minus x square multiplied by x minus 1. So this is minus x cube minus x cube plus x square, right? So if you write it down here, plus x square. So if you notice, I have left some space here in order to write this x square term. That is, this is in this term the degree is 3, in this term the degree is 1. So just leave some space in case you get a term of degree 2. Okay. Now let's subtract. Before that, let's change the sign. Here, since there is no x square term, minus x square will come down and minus x cube plus x cube will get cancelled off, and let's write it down here, minus 3x, and the next term is minus 1. Alright, now again minus x square divided by x will be minus x. Now x into minus x into x is minus x square, minus x into minus 1 is positive x. While subtracting, we need to change. This is minus 3x minus x, that is minus 3x minus x. Answer will be minus 4x. So this is minus 4x. This and this will get cancelled off because it's minus and this is plus. Next, bring it down. Again, we need to repeat. Minus 4x divided by x. Answer is minus 4. So my quotient will be minus 4. Now multiply. Minus 4 into x is minus 4x. Minus 4 into minus 1 is positive 4. Now next we will subtract. Minus 1 minus 4 is minus 5, and this is minus 4x plus 4x, 0. Now the remainder is 0. I will stop here because in this case the degree of this 5 is less than the degree of the divisor. Okay, here the degree of this polynomial is 0 because this is a constant polynomial and the degree of the divisor was 1. So we will stop the division here. We cannot continue further. All right. So now this is the quotient and this is the remainder. Now let's use the remainder theorem. That is, by remainder theorem we know that if the divisor is a linear polynomial, then we can find the remainder easily without this long division, right? So in this case, first of all, you need to check if your divisor is a linear polynomial. So in this case, my divisor is x minus 1. Thus, it is a linear polynomial. Now 0 of this divisor polynomial is 1. That is, I equated my divisor polynomial to 0 and then I found the 0 of this polynomial, that is 1. Now I'll find P of 1. By the way, P of x is 3x raised to 4 minus 4x cube minus 3x minus 1. Now I'll find the value of this P of x at 1. 3 into 1 raised to 4 minus 4 into 1 cube minus 3 into 1 minus 1. 3 minus 4 minus 3 minus 1. And the answer is minus 5. And minus 5 is our remainder from the long division method. Thus we proved the remainder theorem.